Hey guys, so today we're going to be learning about segments and angle measurements. So it's all going to add up. So our two learning targets today are going to be to apply segment addition postulate to find lengths of segments, and then to use the definition of midpoint to find lengths in segments. So in geometry, axioms or postulates are statements that are accepted as true without proof. So that's kind of important, so I'm going to underline it. Accepted as true without proof. So postulates, we believe they are true without having to prove it. Like a point, line, and a plane, distance along a line is an undefined term. So remember, we've learned point, line, and plane are all called undefined terms. We can also now add that the distance along a line is undefined. We know it is true. So for example, the length of a line segment is the distance between its two endpoints. Okay. Let's look at this math term up here real quick. So it says to prove a rule, at least one other rule must be used. So in order to develop geometry, some rules, called postulates, are accepted to be without true. Okay, so that's how geometry was formed. Okay, so if 2 points are no more than 1 foot apart, you can find the distance between them using an ordinary ruler. Okay, so we've got a little ruler on this page over here. You should have a ruler in your hand right now as well. So this distance from A to B would be 5 inches. Okay? So in the figure, the distance between A and B is 5. Of course, there's no need to place the zero of the ruler on point A. In the figure below, the 2-inch mark is on point A. In this case, AB measures in inches is absolute value of 7 take away 2, or 2 take away 7. So in this example down here, I don't need to place my ruler on 0. Again, you can, but we don't have to. So you just need to place it on any whole number. And then if you're asking yourself what the distance between 2 points are, you're going to subtract them and then make sure you take the absolute value because distance cannot be negative. So I always do the bigger number first. The right number, 7 take away 2, is 5. So I know that that length of the line segment is going to be 5 inches, for example. Okay. All right, so the number obtained as a measure of distance depends on the unit of length. For example, the distance between 2 points in inches will be a different number than the distance between 2 points in centimeters. Okay, so units matter. So let's look at centimeters now. And if you have a ruler, it's probably actually going to say millimeters. So I made my ruler match y'all's. So what we're going to do is take your handy dandy ruler. We're going to put point D at 0, and then ask ourselves how far did it go from D to E. So I've got 1 millimeter, 2 millimeter, and then a half. So that'd be 2.5. Okay. So now I'm going to do the same thing for E and F. I'll put E at 0. So now we've got a little decimal going on. So here is 5, here is a half. Each tick mark is like 0.6, 0.7, 0.8, 0.9 to get you to 6. So this will be 5.5, 6, 7 because it hits the second smallest tick mark. So 5.7. And then last but not least, the whole line, DF. So this goes to 8.1.2. Okay? All right, so the ruler postulate is for every pair of points, there corresponds a unique positive number called the distance between the 2 points. Okay? So again, distance cannot be negative. So that is how you measure something. Hopefully we knew that. But what do you notice between these 3 numbers? Because I know this is 2.5, this is 5.7, and then the whole thing is 8.2. So the reason that makes sense is if I add these 2 segments together, if I add 2.5 plus 5.7, I actually get 8.2. Okay, so that's kind of how you can double check to see if you're correct. All right, so what I want you guys to try now is to measure these segments. So you all try number 2. You're going to find the measurement of those 3 line segments. Make sure you round to the nearest tenth, aka the nearest decimal. And then on number 3, describe any patterns you see. And then press pause and we'll go over them. Guys, so when you measured this first segment over here, you should have gotten 4.9. When you measured the other segment, HG, you should have gotten 5.7. And then last but not least, you should have got 10.6 for the whole entire line. And so number 3 wanted you to describe your results and any patterns. And so I kind of talked about it previously, but if you add these 2 smaller segments together, you are going to get this longest segment. Okay, so it's going to introduce us to our segment addition postulate. Okay. So let's talk about that. So it says, given that N is a point in between endpoints M and P of line segment NP. So in geometry, I'm always going to draw a picture to help me visualize what's happening. So I have endpoints M, and I have an endpoint P, and N is somewhere in between it. It doesn't have to be in the middle. You could put it in the middle if you want to. I'm not going to for this example. All right, describe how we can determine the length of MP, and MP is going to be the whole entire thing, without measuring if I already know the lengths of MN, which is this first part, and then NP, which is my second part. Okay, so how can I find the whole line when I know the 2 smaller parts? We kind of already answered it up here. If you know the 2 smaller segments, you can add them together to get the longest one. So let's go ahead and write a formal definition for the segment addition postulate. So it's going to be NN, so that first segment, plus NP, my second segment, is going to equal my whole, which is MP. And remember, I only need 2 letters to name segments, so I don't need to name it MNP. So a trick is part plus part equals whole. Okay, so one part plus the other part is going to get you to your total whole segment. Okay, and that is a segment addition postulate, which is what we're learning today. So let's get to some practice with some numbers in algebra. All right, so number 5, it wants to use the segment addition postulate given the information below. So I will do A and C with y'all. So again, drawing a picture is going to help you out so much. Okay, it even tells you to sketch. It's going to help us out. So B is between points C and D. So I'm going to draw a line segment. My endpoints are C and D. B is in between it. Again, I don't have to put it in the middle. I just need to put it somewhere. All right, now I need a label. It says BC is 10 inches. So this first part is 10 inches. BD, the second part, is 3 inches. And then it says, what is CD? And CD is the whole thing. So remember, part plus part equals whole. So 10 plus 30 is 13. Okay. On part B, it says that Q is between R and T. So I'm going to draw a line segment R and T. I'm going to put Q somewhere on the line. Again, doesn't have to be in the middle. And now I'm going to label. So this one actually gives me the whole first. The whole entire thing is 24. How I tell the whole is this big kind of arrow. And then I write 24. QR is 6. So this first part is 6. And then I'm trying to find the second part. So maybe you can do this in your head. I'm going to set up an equation first. So if I don't know this, I'm going to call it x. So for example, 6 plus I don't know is going to equal 24. And so I would subtract 6. So, or you can know that, hey, I need to do 24 minus 6 to give you the other part. And that's going to give us 18 centimeters. And that about my units. This should have been inches. Okay, so that's an example of just numbers. So again, part plus part equals whole. But again, if you know the whole entire thing, you can subtract a part to find the other part. All right, let's do one more, and let's talk about some equations. So it says P is between L and A. So I'm going to draw a line segment, L and A, with P somewhere in between it. I'm going to label my parts now. So PL, the first part is x plus 4. The second part, PA, is 2x minus 1. And then the whole entire thing is going to be 5x minus 3. Okay? So again, part plus part equals whole. So let's set up a nice equation of the first part, x plus 4, plus the second part, 2x minus 1, equals the whole entire thing of 5x minus 3. Okay? So now we're going to go back to algebra. So if I've got terms on the same side, I like to circle them and add them. So x plus 2x is 3x. Same thing over here, I have a 4 and a negative 1. So 4 minus 1 is 3, equals 5x minus 3. So now you've got variables on both sides. I'm going to draw my wall. I'm going to move the 3x to the right side. Again, you could do this problem 4 ways. But I'm going to get my variables to the same side by doing the inverse operation. Bring down your 3, equals 5 minus 3x is 2x. Bring down minus 3. Okay? Last but not least, my numbers need to come over here to the left side, so the opposite of a negative 3 is a positive 3. That will cancel out, leaving you as 6 equals 2x. Divide by 2, so that x is 3. Okay? So now I've completed the first part of my problem. It wanted me to say x was 3. Okay? So that one is done, but it also wants me to find LA. And LA is this first part. No, it's not. It's the whole thing. So luckily I have an equation for the whole thing. So I'm going to substitute in 3 for your x, like so. So 5, and substitute with parentheses, 3 minus 3. Okay, so 5 times 3 is 15. 15 minus 3 is going to be 12. So the length of LA is going to be 12, and they didn't give me units. So 12 inches, centimeters, oh no. Okay. All right, guys, so that is the basics of the segment addition postulate. They get a little bit trickier, but again, you guys can do it. So if you have any questions on that, let me know. Otherwise, we're going to move on to one quick thing on midpoints. Just kidding, we're going to end this video. So if you're done, if you have any questions, let me know. Otherwise, go ahead and watch part 2.